Hi everyone, this is Mrs. J, and today we're going to be solving quadratics by completing the square. But first, please pause the video and give this warm-up a try. All right, go ahead and check your work. For part A, I used factoring to solve this. So I set my equation equal to 0. I factored into x minus 3 and x minus 2, and then I used the zero product property to finish solving. For part B, I used the square root method because I noticed that there's an x squared term, but there's no x term. So I isolated x squared, and I took the plus or minus square root of both sides to get plus or minus 3i. Notice here I said find all solutions. So imaginary or complex solutions are fair game from here on out. So really quick, I just want to revisit this roadmap that we have for all of the different methods that we are going to use for solving quadratic equations. So factoring we have done, graphing we've done, the square root method we've done. Today we are going to be doing completing the square, and then in our next class we're going to use the quadratic formula. So we're almost through all of our methods for solving quadratics. So before we talk about this process of completing the square, I want to talk about an important concept called a perfect square trinomial, which is essentially what we're going to be creating today. So these are all examples of perfect squared trinomial. So one thing to note is that they all have 3 terms, which makes them a trinomial. But I want to talk about, well, why are they called a perfect square trinomial? If you factor this first trinomial using magic x, the 2 factors are x plus 1 and x plus 1 is the same factor twice. So in factored form, we could write that as x plus 1 squared. So we see that when we factor it, it becomes a binomial square. If you look at the second one, their factors would be x minus 2 times x minus 2, so that becomes x minus 2 squared. For the third one, it becomes x plus 3 squared, x minus 4 squared, x minus 5 squared, and here we would have x plus 6 squared. So you could see that perfect square trinomials can always be factored into a binomial squared, and that's why we call them perfect square trinomials. So let's take a look at some patterns that we notice here. First, I want to ask if you notice anything about all of our C values. Our C values are these constants. We have 1, 4, 9, 16, 25, and 36. So hopefully you notice that all of the C values, they are all perfect squares. Right, we have 1 squared, 2 squared, 3 squared, 4 squared, so on and so forth. And again, these are just some examples of perfect square trinomials. There are an infinite amount of perfect square trinomials. Next, I'd like you to see if you notice any relationship between the B value, which is the coefficient of your x term, and your C values. So if you look at this first one, here my C value is 1, which is 1 squared. Here my B value is 2. Here my C value is 2 squared, and here this is negative 4. Here it's 3 squared, and here it's positive 6. So maybe you're starting to notice that if you take your B value, you divide it by 2, and you square it, you get your C value. So let's see if that works. Well, half of 6 is 3, and 3 squared is 9. Half of negative 8 is negative 4. Negative 4 squared is 16. Half of 10 is 5, negative 5 squared is 25. Half of 12 is 6, 6 squared is 36. So we could see that the relationship between the C values, well, the C value equals the B value divided by 2 and then squared. So this is actually a formula that we're going to use to help us create these perfect square trinomials. We can always find that, I call it the magic number, which is just the constant, by taking your B value, cutting it in half, and squaring it. So another thing you might have noticed is that your C value is always positive, regardless of whether or not your B value is positive or negative. So here, since we're taking our B value, cutting in half, and then squaring it, that process of squaring your number will always create that positive number. So our C values are always going to be positive, but sometimes our B values are positive and sometimes they're negative. Now last, I want to see if you notice any patterns between your trinomials and your factors. So maybe you notice that, well, the number in your factor is the square root of your constant, and it's also equal to half of your B value. So we could say that the factor is always x plus half of your B value, right? So this number here, again, is always going to be half of your B value. And let's check that for all of them. Well, here, 1 is half of 2. Negative 2 is half of negative 4. 3 is half of B, so on and so forth. So you might also notice that when your B value is negative, the number in your factor is negative, and when your B value is positive, the number of our factor is positive. Okay, so today we're going to be creating a perfect square trinomial with the intent of factoring it into a binomial squared, which will allow us to solve our equation. Before we actually get to solving, I want us just to practice completing our square. So we want to create that perfect square trinomial and then factor it. So we're not solving yet, we're just practicing that first step. So here I have x squared plus 14x, and again, I need to know my C value that completes my square. So I know that the C value is always going to be half of the B value squared. So here, when we know that half of 14 is 7, and 7 squared is 49. So that's the C value that completes our square. So x squared plus 14x plus 49. And then if I go to factor this, since it is a perfect square trinomial, I know that the number in my factor, this number here, should be half of my B value. So it's x plus 7 squared. Or you could always use magic x to help you factor it. You'll get the same thing. All right, here we have x squared minus 18x, so let's complete our perfect square trinomial. I'm going to take my B value again, cut it in half, and square it. So negative 18 divided by 2 is negative 9, and negative 9 squared is 81. So we get x squared minus 18x plus 81, and that would factor into x minus 9 squared. So notice again, it's half of your B value is always going to be in the number inside your factors. All right, go ahead and pause the video and give these two a try on your own. Okay, go ahead and check your work. For part A, your C value, your constant should be 64, and then that gives you the factors x plus 8 squared. And for part B, your factor should be 100, and when it's factored, it becomes x minus 10 squared. So make sure you have a negative 10 for part B. All right, let's give this one a try together. You could see here we actually have an equation, so we're going to solve. But I kind of spell out for you how to go about this. So first, it says factor the left side of our equation. If you look at the left side of our equation, it is already a perfect square trinomial, right? If you take this number, negative 12, cut it in half and square it, we get this C value. So this is a perfect square trinomial already. So it factors into x minus 6 squared equals 12. And then it says finish solving using the square root method. So here you could see we have a term being squared, and we know that we get rid of a square by taking the plus or minus square root of both sides. And yeah, we're going to take the plus or minus square root of the entire thing. So it just becomes x minus 6 on the left side, and on the right side it becomes plus or minus square root of 12. Then all we need to do is finish solving for x. I'm simply going to add 6 to both sides, and we get 6 plus or minus the square root of 12. So notice that I cannot add a radical and a non-radical. And when we write our answer, we typically write your non-radical first. So we have 6 plus or minus the square root of 12. Now, as always, we're going to make sure that our final answer is fully simplified. So I know that the square root of 12 is 4 times 3. and 4 is a perfect square. So we have 6 plus or minus 2 root 3 as our final answer. So this process of taking a perfect square trinomial, factoring it, and then taking the plus or minus square root is what we're going to do today. So we are going to have to add in one extra step, but this is the general idea. Again, we have a perfect square trinomial, we factor it, and then since it's a binomial squared, we can finish solving by taking the plus or minus square root of both sides. So here are the steps for solving a quadratic by completing the square. I'd like you guys to refer back to this slide if you need to as we're going through the process, but essentially we're going to start by moving the x squared and the x terms to one side, and we're going to move the constant to the other side. And here's a pretty important step. We do need to make sure that the coefficient of x squared is equal to 1. So if the a value is something other than 1, we need to divide it away from every single term. And then we're going to complete our square. So remember, we use that b over 2 squared to complete our square, and then we're going to add that number to both sides of our equation, always making sure we're keeping equality. And then we're going to factor, just like we did in the last example. We're going to take the plus or minus square root of both sides, just like we did in the last example. And then we're going to finish solving for x, making sure that your radical is simplified if necessary. All right, let's give these two a try together. So for part A, you can see that step 1 is already done for us. We have our x squared and our x term on one side, and our constant, which is always the term without the variable, on the other side. So now I want to turn the left side into a perfect square trinomial. So I need to find that c value. Remember, we always take your b value, we divide it by 2, and we square it. So we get negative 2 squared, which is positive 4. So this is an equation. So we need to make sure that anything we do it to both sides to maintain equality. So I'm going to add 4 to both sides. Don't forget to add it to the right side of the equation. So when I do that, you can see that I've created a perfect square trinomial on the left side, which I'm then able to factor into x minus 2 squared. And then I can do the process like we did in that last example of taking the plus or minus square root of both sides. And then all I need to do is finish isolating x. So add 2 to both sides, and we have 2 plus or minus the square root of 10. Square root of 10 cannot be simplified, so that means that this is my final answer. All right, let's look at part B. So if you look at these numbers, this is not a perfect square trinomial. 6 divided by 2 is 3, 3 squared is 9. So this is not the number that we want. So the first thing I'm going to do is I'm going to move that constant to the other side. So remember, we want the variables on one side and the constant on the other. So now I need to find the number that completes this perfect square trinomial. So let's find our c value. Take your b value, cut it in half, and square it. So here we get, again, c equals 9. So I'm going to go in and I'm going to add 9 to both sides of our equation. We get negative 3 on the right side. So now we have a perfect square trinomial, which can be factored into x plus 3 squared. And now we can take the plus or minus square root of both sides. Don't worry about the negative. Remember, we now know how to work with imaginary numbers. And then let's finish solving for x. So negative 3, because we're subtracting 3 from both sides, plus or minus the square root of negative 3. And then we just need to make sure our answer is fully simplified. We can't simplify the square root of 3, but we can simplify the square root of negative 1. We know the square root of negative 1 is I, so it becomes negative 3 plus or minus I root 3. So here we have two solutions, but in this case, they are two imaginary solutions. In part A, we have two real solutions. All right, go ahead and pause the video and give these two a try. If you get stuck, look at the last example and see if you can follow the same steps. All right, go ahead and check your work here. For part A, our magic number is 16, which you can say I added to both sides. Then I factored my perfect square trinomial. I took the square root plus or minus square root of both sides. I subtracted 4 from both sides, and then I simplified my radical. So negative 4 plus or minus 2 times the square root of 5. For part B, you do need to do that first step of moving your constant to the other side. Here's how I found my C value that completes the square. So I added 1 to both sides. Don't forget to add it to the right side. I factored my trinomial. I took the plus or minus square root of both sides. I finished isolating x, and then I simplified my radical. The square root of negative 1 is just I. All right, let's try another one together. So let's start by moving our constant to the other side of the equation. So I'll subtract 9 from both sides. Now, if you remember in the steps for completing the square, it did say that our a value has to be 1. That b over 2 squared formula does not work unless your a value is 1. But here you can see our a value is 3. So we need to fix that. How do we turn a 3 into a 1? We divide by 3. But since it's an equation, we have to do the same thing to both sides and every single term on both sides. So I need to divide every single term by 3. So I have x squared minus 10x equals negative 3. So from here, I am now ready to complete the square. So when your a value is something other than 3, just remember you need to divide it away before you start your process. Those are definitely trickier problems. Let's find our constant that completes the square. So we have our b value cut in half squared. So negative 5 squared is 25. Don't forget to add it to both sides of the equation. So x squared minus 10x plus 25 equals 22. And now I can factor my perfect square trinomial. And I can take the plus or minus square root of both sides. And I can finish solving for x. Here, 22 is just 2 times 11. Both of those are prime numbers, so this radical is fully simplified, and we are all done. So the only extra step in this problem now was making sure that our a value equals 1 before we complete the square. All right, go ahead and pause the video and try one of these on your own. All right, go ahead and check your work here. Please make sure you divided both sides by 2 before you completed the square. Please make sure you added 9 to both sides of your equation. And please make sure that you have the plus or minus square root of 11 here. Don't forget about that plus or minus. And then here's our final answer. Okay, here we have one challenge problem that we're going to work through together. You may have noticed that in all of these examples, our b values have all been even. Now, here we have an example where our b value is odd. We can still absolutely solve by completing the square. We just have to be a little bit more careful because we will be working with fractions, which is why it's a challenge problem. But we're going to follow the exact same process. Let's start by moving our constant to the other side. And let's find our c value using the same process. So we take our b value, we cut it in half, and we square it. Now here, we don't want to write this as 2.5 squared. We want to leave it in fraction form. We just need to square the numerator and the denominator. So it becomes 25 over 4. And that I am going to add to both sides. Okay. So here we have x squared plus 5x plus 25 over 4. When you're adding up fractions with unlike denominators, I always recommend just go to the side and do it rather than trying to do it in our head. So we know that 2 is just 8 over 4. So we have 8 over 4 plus 25 over 4, which is 33 over 4. So if we just take a second and do it on the side, it's really not that difficult. Now, from here, you might be thinking, how in the world do I factor this type of trinomial? And here's where it's really important that we notice those patterns. Remember, in our factors, we always have x, and then it's going to be whatever your b value is divided by 2. It's always half of your b value. So it's plus 5 over 2 squared. So again, looking for patterns in math is always extremely important, which is why we took the time to do that at the beginning of the lesson. Now let's keep following our steps. Let's take the plus or minus square root of both sides. I'm taking the square root of the entire right side, the numerator and the denominator. And then I'm going to finish solving for x. I'm going to subtract 5 over 2. And then the last thing I'm going to do is simplify my radical. My numerator cannot be simplified, but my denominator can. So we still have plus or minus. I'm going to leave the square root of 33 in the numerator, but in the denominator, the square root of 4 is 2. So we can leave our final answer like this. That's completely fine. Since they have the same denominator, if you would like to add up the numerators and write it like this, that is also completely fine. Either way, they're equivalent expressions, so either way is a very acceptable answer. So again, this is definitely a challenge problem, and maybe you can see that if your b value is odd and you have the choice of picking your method, maybe completing the square is not the method to choose. Okay, now we're going to look at another useful application of completing the square, which is rewriting a quadratic equation in vertex form. So here we have a quadratic equation in standard form, which we should be able to graph from this form, but for some of us, we might prefer to graph from vertex form. So we're going to try rewriting it. Now, if we remember what vertex form looks like, it looks like a times x minus h squared plus k. We like graphing from this form because we can see that the vertex is just hk. Now, if I look at where I'm starting and where I want to go, I can see that I have to create this binomial squared. And that's where we're going to use this process of completing the square. So this is our first goal, is to make this. Well, if I want to make this, I'm going to start with just the x squared and the x term. So I need to move this 7 to the other side. And in this case, we're keeping the y in the equation. So we have y minus 7 equals x squared minus 4x. So now, in order for me to turn this into this, remember I need to complete the square. So you take your your b value, which is -4, cut it in half, and you square it. And so we get c equals 4. This is still an equation, so I need to make sure that anything I do, I am doing it to both sides of my equation. Don't forget to add it to this side. That's where everyone makes that small mistake. So we have y minus 3 equals x squared minus 4x plus 4. So now we have our perfect square trinomial, which we can factor into x minus 2 squared. Now, if you look at what we have and where we want to go, the only thing we have left to do is just to add 3 back to the other side. So we have y equals x minus 2 squared plus 3. And there's our equation. So from here, we could easily see that our vertex is +2, +3, and we could graph pretty quickly. But again, we should also be able to graph from standard form. This is just a useful application of completing the square. All right, here is your last U-try. Please pause the video and give it a shot. All right, go ahead and check your work here. So I added 3 to both sides. The number that completes my perfect square trinomial is 16. Please make sure you've added it to both sides of your equation. Then you can factor and solve for y again. So you can see that your vertex is -4, -19. All right, that's all for today's video. Thank you so much for watching.